Okay, so we want to prove by contradiction that if A times B is odd, then both A and B are odd. So remember, with contradiction, we want to assume the negation of the statement, right? The entire statement. As you can see, this is of the form if P, then Q, right? If A times B is odd would be P, and A and B are odd is proposition Q, right? This is of the form if P, then Q. Both A and B are odd, right? So we can see that we want to assume the negation of P implies Q, and we know that the negation of P implies Q is logically equivalent to P and not Q, okay? So what we're going to do here is we're going to assume the negation of our statement, which is the negation of P implies Q, but we're going to use this instead, right? And then we're going to get to our contradiction. So let's go ahead and start our proof. So we're going to assume, okay, AB is odd, right? We're going to assume P. And we're going to assume not Q. So the negation of Q would be A or B is even, right? A or B is even. Okay? So if we have A or B is even, right? We can break this up into two cases, right? So case one, A is even, right? Okay. So, and it doesn't even matter what B is, right? And I'll show you in a second, because if A is even, then this implies that A is equal to 2K, where K is an integer. And regardless of what B, if B is even or not, right? This implies that A times B is equal to 2K times B, right? Because A is equal to 2K, which equals 2 times KB. And if K is an integer and B is an integer, right? That means K times B is an integer. So we can write A times B of the form 2 times an integer, which means A times B is even, right? And for the second case, right, we would have B is even, right? Oh, B is even, and of course that implies that B is equal to 2Q. Let's just write Q, where Q is an integer, right? So this implies that regardless of what A is, right, A times B is equal to A times 2Q, right? Which we can rewrite this as 2 times AQ. And A is an integer and Q is an integer, right? So that means A times Q is an integer. So we're able to write A times B as 2 times an integer, which implies that AB is even, right? So, regardless, right? We have that if A or B is even, then A times B is even. But look, we assumed that A times B is odd. So we cannot have A times B is odd and A times B is even. That is our contradiction, right? A contradiction, right? So thus, that means that our original statement must be true, right? It must be the case that if A times B is odd, then both A and B are odd, because we assumed the opposite of it, and assuming the opposite of it led to a contradiction. Thus, if A, B is odd, right? If A, B is odd, then A, then both, right? Both A and B are odd, right? Then both A and B are odd. And that is the proof.